Hello, Mr. Sunday.
I can hear you.
Yeah, on Tuesday, personally here I'll be engaged in another exam. I don't know if the exam is available until late in the evening or you just have to take it during the day.
Or you have another exam on Tuesday?
Yes.
Then make sure. Yes. Just make sure that you book for the Monday session. Do your assignments, take me the screenshots and book for the Monday session. Don't wait for the Tuesday session.
All right.
All right. Okay, so
excuse me, Mr. Sunday.
Please, I'll take questions after. Okay, just one more last question.
I would like to inquire from you about the exam. I was actually in the previous class and I happened to have a voucher for the final exam, but I got disappointed because of a network problem, which had stopped me on the 25th question. So I was unable to finish the session and the system had submitted. You talked of the policies. I don't know if it couldn't like affect like particularly me who is coming back to do it this time around.
I told you guys, because of what happened, that I was going to make special arrangements for you. I am a man of my word. I did not lie to you, so it's not going to affect you.
Okay, please. Thanks.
All right, so let us look at dual system hot standby. For the people who have been dealing with IT things, you have heard of the word standby, and even if you have not been dealing with IT things, maybe let's say you're in the security, aspect of life, maybe the real security, the one for with guns, and someone tells you you're on standby. I think that rings a bell to you, and by the fact that standby means that you are ready, waiting to take on something, isn't it? Right? And for those who have been familiar with the IT terminologies, what does the word hot mean?
Active.
It means active, right?
Active. Yeah.
Yes. So meaning you have a device that is actively waiting to take on the role, that is on standby, waiting to do something, isn't it? So we want to be looking at dual system hot standby today. And with rapid development of services such as mobile office, online shopping, instant messaging, internet finance, and internet education, networks carry increasing services, and therefore they have become more important. How to ensure uninterrupted network transmission is an issue that needs to be solved urgently during network deployment. Remember, in our traditional network deployment, we have our intranet, which we said to connect to it, you must connect it through our firewall for you to be able to connect to the internet. But now the scenario is maybe because of power issues or because of something, your firewall breaks down or it is interrupted. Do you think clients out there who want to access your services will be able to access your services much as they're authorized if your firewall broke down for one reason or another?
No.
They will not be able to access the services because the device which is supposed to authenticate them anyway is not available. So we need to ensure that there's uninterrupted network transmission. And that's why, either network engineers or security engineers decided to come up with what they're calling dual system hot standby, which is going to be improving reliability, basically for redundancy. So two firewalls can be deployed at the egress or at the entrance of a network to ensure that communication between the intranet and internet takes place. So instead of having one firewall, we can have another powered on firewall, much as it's not the one which is actively taking charge of the packets taking through, but it is in standby mode. It is just there waiting in case this guy is unavailable. Our network, our communications shouldn't be interrupted. Let me take over his role as maybe they fix him up and sort out what the issue is, so that our clients or our end users who are authorized can continue transmitting and sending data. So upon completion of this course, you'll be able to master the principle of dual system hot standby and also master the basic configuration of dual system hot standby. Let us look at the technical principles of dual system hot standby. And why must we use dual system hot standby? It's a question we're asking ourselves today. So as a security device, our firewall, like you can see in this illustration, it is usually located at a service connection point, the connection point between our intranet and our internet. And it's usually between our to be protected network. This is our to be protected network, and this is the unprotected network. So if only one firewall is deployed at this service point, network services may be interrupted due to a single point of failure, no matter how reliable the firewall is. And to prevent this kind of scenario and to prevent service interruptions due to a single point of failure, because if you're using a single firewall, by all odds, there is a single point of failure. So we can then choose to deploy at least 2 firewalls to form what we are calling a dual system hot standby. Just like you see in this following figure, it shows the traditional networking mode where packets are exchanged between the intranet and the internet. And the internet, they're exchanging or they're going through firewall A. So if a firewall is faulty, if this firewall becomes faulty, then the intranet hosts that use firewall A as a default gateway cannot communicate with the internet after, and this will lead to or will affect our communication reliability. And that's why we are looking at dual system hot standby. So they are looking at a mechanism, they're looking at redundancy, and we want to look at redundancy deployment solution for routers. Just like in routing networking, virtual router redundancy protocol, the VRRP, which is a protocol. This protocol can be used in Huawei's layer 3 devices, and also some other industry devices use this kind of protocol. It is used for router redundancy. A common solution to a single point in failure in a standard router networking is set up a protection mechanism based on the failover links between a dynamic routing protocol. However, this protection mechanism has limitations. So if the dynamic routing protocol is not available, services may be interrupted due to a link in fault. So to address this problem, another protection mechanism comes up, like the virtual router redundancy protocol. It is introduced, and it is a basic fault tolerant protocol, and it brings a short failover duration compared with the broadcast packets that depend on a dynamic routing protocol like the OSPF. So this one helps us to reduce the period of our failover, and it provides link protection even if no dynamic routing protocol is available. So how it happens, it creates what they are calling a group, and a group of routers in the same broadcast domain to form a virtual router. So they're going to get this router A, router B, and router C, and they're going to combine them and put them into what we are calling a group. And a group appears as a virtual router, but it's basically a combination of routers within the same broadcast domain. And all routers in the group provide a virtual IP address as the gateway address for the intranet. So you're going to come up with a virtual IP address, which you're going to assign your routers, and all of them are going to have this virtual IP address as their default gateway. as you can see, they are all within this same network segment of .10.10.10. So they have to be within the same network domain. And among these routers, we have what we are calling a master router. And basically a master router is among the routers in the same VRP group, and it is the only router which is active. So only the master router can forward packets with the virtual IP address as the next hop. So when it's receiving packets and it's forwarding them, it forwards them to the virtual IP address as the next hop. And part of these routers, other routers which are not master routers, are what we are calling the backup routers. And except for the master router, all routers in the VIP group are on standby. So these guys are on standby. They're waiting to see if the master goes down, then one of them will assume the role of the master router. So what happens here is that the master router periodically sends a hello packet to the backup router in multicast mode, and then the backup routers determine the status of the master router based on the hello packet, to just make sure this guy keeps on sending hello, are you still there, are you still backing me up, to make sure that the body gets around. And these guys will use those packets to determine if this guy is still available. And because the VRP hello packets are multicast packets, the routers in the VRP group must be interconnected through layer 2 devices. No any kind of routing can work. So you can have your switches and they can be interconnecting our routers in that mode. So when the VRP is enabled, the upstream and downstream devices must have a layer 2 switching functions. Otherwise, routers cannot receive hello packets sent by the master if they are not on layer 2, and let's say you have a different network segment. So they must be on the same network segment to be able to send the hello packets. So if you cannot afford to have that kind of networking environment or requirement, then you should not use VRP mode. So that's way we can the application of VRP in multi-zone firewall networking. So you want to transfer that application of VRP in our network mode. Someone is saying they can't hear. Someone is saying they can't hear.
We
Can
are
you
hearing.
guys-
We're able to get you clear.
Okay, can someone help me type in the chat and inform Mwape na Beye to either tap on connect via device audio so that he can fix his problem. All right. So we want to see how we can apply a VRP in multi-zone firewall networking. To provide your hot standby for multi-zones on firewall, you must configure VRP groups. So if you want to provide dual system hot standby for multi-zones on your firewalls, you must configure the VRP groups. And if multi-zones on firewalls require the hot standby functions, like I said, you have to make sure that you have multi VRP groups on each firewall, like firewall A and firewall B. And as firewalls are stateful firewalls, remember we talked about stateful inspection. We said, what does it do? Who remembers?
Mic check.
Yes, please go ahead.
I think stateful inspection firewalls start by checking the first packet to see if it meets the policy that have been put in place. And then if the packet meets the policy, other packets that follow would just be allowed to pass through the file.
Okay, thank you. So basically it checks the first packet and then updates the session tables, and then the subsequent packets are just processed as subsequent packets. So we are saying that most of our files that we're using work in a stateful firewalls, and they require the forward and reverse packets to pass through the same firewall, right? Because remember now the session table has been created on this firewall. So if it breaks up, it breaks up in the middle of a transmission, and other packets are going to come and go through firewall B, then there's a problem. Because remember now, firewall B does not have the session status of those packets, isn't it? And if it doesn't have, and remember I said if subsequent packets come and it checks the session table and they're not there, it will just go ahead and discard them. So we're already seeing a problem there. So to meet this requirement, the status of all VRP groups on a firewall must be the same. Yes, so what is on firewall A must be also what is on firewall B. They must be the same. That is, all VRP groups of the firewall, of the master firewall must be in the same. They must be the same as that of the master, so that all packets can pass through the firewall, and the other firewall functions as backup firewalls. Remember, we talked about the trust zones. We have different trust zones. We said we have the trust zone. I think it goes up to 80. We also have the demilitarized zone, DMZ, which has about 50 numbers, and we said we cannot, by these are the default numbers assigned to them, and we cannot change them. And we also have untrust. Because it's untrust, it has only about 5. And also we said we have the local zone. Because local zone, this guy is actually, because he's the one controlling anyway, so he's the most trusted, and his number is 100. But that is something that we just wanted to hit on, not to take a lot of time on it. So the defect of VRP in firewall application. So we said in traditional VRP mode, the status of the master firewall cannot be consistent with that of the backup firewall. At least there's some time that will take for it to be the same as that of the backup firewall. Like I said, you have your packet here from PC1, it's going to go through the master, the session entries are going to be updated, and subsequent packets will be allowed to go through the firewall and go to our PC4, which is good, and which is also okay. But now what will happen? What will happen? The file packets will come back still, and they'll be able to reach their intended destination, which is okay. They'll go through that because we have our sessions which are updated there. But now, because of interruption or service interruption, something happens and this firewall is off. If a packet comes and it is routed through our backup firewall and the sessions have not been updated, these packets definitely are going to be discarded, because this guy does not have the sessions. Even when you choose to synchronize, there's some kind of time that is going to wait for to get the status of master A, of firewall A to be the status of firewall B. So the causes of the problem is that for example, if it's a router, each packet is forwarded based on the routing table, and after a link switchover, the subsequent packets can still be forwarded. For the router, it's okay. But in stateful firewall, if the firewall packet is allowed through the firewall, and the firewall creates a quintuple session. Remember, we talked about quintuple. It updates the session and says, you know what, this is what I need. I need to store the MAC address, SSID, and it's updated in our session table. But now remember, if the subsequent packets, including the reverse packets, matching this session entry, and they want to pass through the firewall, if there has been a switch over, this firewall has gone off, and this one has assumed the responsibility, then subsequent packets cannot match the session entries on this firewall, right? Thus resulting in service interruption. And also note that if there is a NAT configuration, if NAT has been configured on a router, similar problems also can occur, because an entry has to be created after NAT has been. So an entry on the, how we generate our server map entries has to be created if you have configured NAT on the routers. So to use of VRP for firewall multi-zone, the requirement for the application of VRP on firewall you need to make sure that the status is consistent, and also need to make sure that you back up your session table status. So they have to be consistent, and also make sure that your session table status is backed up. And multiple VRP groups in a firewall can be added to a VGMP group, which manages our VRP groups in a unified manner. VGMP, we're going to look at it, and it controls the status switchover of our VRP groups in a unified manner, ensuring that there's consistency in status of our VRP group. So it has a way of managing all these firewalls to make sure that the switchover is synchronized and everything is in a unified manner. So to ensure that there's switchover consistency of all VRP groups, the VRP group management protocol is developed based on the virtual router redundancy protocol. So basic principles of the virtual group management protocol. And if the VGM group on a firewall is in the active state, then all the VRP groups in the VGMP group are in the active state. And the same applies with the standby one. The firewall in an active state regularly tests the peers running status, including the priority and VRP member status, by sending hello packets. So those ones were saying, how do you determine? You can first configure what is your active firewall, and then depending on that, now you can also use this protocol to manage. I saw someone asking how can we use to consider which one is a backup and which one is a master. So we can use this protocol, and this protocol can help us choose. And even after, when this guy is restored, initially you can choose to configure it as the master, and then after you can choose to you can use the VGMP protocol to help you do that. So what will happen is that it will send the hello packets and acknowledgement, and it will check the status, and it will also make sure that everything is synchronized in a unified manner. So you can specify the group status to determine the active or standby. So someone who was asking, you as an engineer, you can specify and say this group 1 is going to be my active, this VGM, and this VGM group is going to be my standby group. Yeah. And if the VGM group on the firewall is in active state, then all the other VRP groups in the VGM group are in the active state. So you have other firewalls in your groups, and they are all in what they're calling the active state. So the firewall is the active firewall, and all packets pass through the firewall. And in this case, a VGMB group on the other firewall is in the standby state, and the firewall is the standby firewall. So if each firewall has an initial VGMP group priority, it has an initial priority number, the priority number which you're going to use to determine which one should be taken on first before we take on the other. So if an interface or a board of the firewall is faulty, the VGMP group priority of the firewall decreases, right? So it will keep checking how many times has this guy failed, and if he keeps on failing more often, the priority number increases, and the one with the most priority will be considered to be the master. So but by default, the initial VGMP group priority of some of the traditional firewalls and the next generation firewall is usually 45,000. And the initial group priority of other firewalls that I've not mentioned depends on the number of cards and processing units that firewall has. So similar to the VRP, the virtual router redundancy protocol, our virtual group management protocol active firewall regularly sends a hello packet. Remember what we talked, it regularly sends a hello packet to the VGMP standby firewall to inform the letter of its running status, to inform it that, hey, you know what, I'm still around and I'm working, so kindly look at me, I'm still around, do not assume my positions, including the priority and the status of the Vmp groups. And the number status is dynamically adjusted so that firewalls can perform active or standby switchovers. So different from VRP, after the VGMP standby firewall receives a hello packet, it replies with an acknowledgement. VRP, remember, there's no acknowledgement. It just receives and keeps quiet and knows that the boss is around. But this guy, whenever he receives an hello, he says, "Oh, okay, I have seen your presence, sir. So there's no point for you to keep on bragging around." So it responds or replies with an acknowledgement message carrying its own priority and status number of the member via RP groups. So by default, the hello packets are sent every second. Okay, every second the master via VGMP active sends a hello packet, and if the standby firewall does not receive any hello packets from the active firewall after the 3 hello packets period, so meaning after 3 seconds, and it has not received anything from that guy, then the standby firewall will regard that the master is not around, and then it will go ahead and assume the master role and take up the responsibility of forwarding protocols, thus us having a reliable network and avoiding the single point of failure kind of network topology. So management of a VGMP group, you need to make sure that there's status consistency management. You need to manage the statuses. The VGMP group controls the switchover of all VRP groups, and preemption management. In case the failed firewall comes back on, should it resume its responsibility as a master? When should it resume the responsibility? Or I should keep being the master, and he also serves as my standby as I assume the duty. So there are 2 ways we look at the station consistency management and preemption management. With preemption management, if the faulty active devices recovers, so does the priority of the device. In this case, the device can become active again through preemption if the active device has come back online. The basic concepts of HRP, this is Huawei's redundancy protocol, and it backs up dynamic status data and key configurations between firewall. Keynote, it backs up dynamic status data and key configuration commands between firewalls. Basically, its role is to back up the data. Some of the data it backs up are TCP or UDP data, session data, and also usually it backs up the firewall with the active VGMP group, backs up that are required or the required data to the peer. And generally the ports that directly interconnect to the firewall are used as the backup channel, which also called the heartbeat link. And the HCIA provides the basic data backup mechanism and transmission function, and each module collects the data that needs to be backed up by modules and submits the data to the HCIA module. And the HCIA module sends the data to the corresponding module of the peer firewall, and the firewall module passes the data submitted to the HCIA module and adds it to the dynamic data of pool for the firewall. So its role is basically to make sure that all the session data, TCP data, and all that is coming through, it's going to go ahead and back it up in the session data. Its role is to back up the dynamic status data and also the configuration commands that you have passed on your firewall. The heartbeat interfaces usually, depending on the amount of data that you have to back up, but the backup data accounts for about 20% or 30% of our service traffic. So you can determine the number of Ethernet trunk interfaces based on the amount of data that you need to back up. But there are 2 firewall exchanging data through the heartbeat interfaces over a heartbeat link. So if the firewalls, there are 2 of them and they're exchanging data, the link that they're using to exchange that heartbeat information is what you're calling the heartbeat link. And the heartbeat interface must be independent interface with an IP address. You must specify the interface and you give it an IP address. It can also be either physical interface, such as a gigabit either interface, a port on the firewall, or it can even be a logical Ethernet trunk. Ethernet trunk is usually what we are calling a link aggregation. You will see it, link aggregation. You bound different links together to come up with your Ethernet trunk. So a status of heartbeat interfaces, HCIA interfaces have different statuses. We have invalid, we have down, we have peer down, we have ready, and we have running, and we wanted to look at some of them. When it comes to invalid, the physical status is up, as you can see, or the computer here and this computer, the status is up, this computer is up and running, it can sense the bit streams, it is up, the physical status is up. Sorry, yes, but the protocol status is down. Yes, there's no protocol that they're going to use to exchange this data. The physical is up, but that's the protocol status is down. This is what we are calling invalid. And the local heartbeat interface is incorrectly configured. Usually, you have not specified. Remember, you said we need to give it an IP address, and it can either be a physical interface or a logical Ethernet trunk interface. So here it is up and running, but you have not configured it correctly. And for example, like the heartbeat interface in layer 2 interface, there's no IP address. It's configured for the heartbeat interface. If the status is down and they're telling you peer down, we're looking at down, and if the status is down, then the physical and protocol statuses of the heartbeat interface are both down. Maybe let's say the firewall is powered off and it is not on, but it cannot sense or detect the link at the end of that side. Then the status will be down of the peer. And then there's also a status of peer down. The status of peer down basically means that the physical and protocol statuses are both up on this computer. Like you have configured on your firewall, you have configured correctly your IP addresses and everything. The protocols, you have configured it, and your machine is up and running and the interface is up, but the peer at the other end cannot be reached, it cannot detect. That's why this link here, status is peer down. It does not mean that this particular firewall is up, but its status is peer down, showing that whatever it's supposed to communicate with, its status is down. That's why we are calling it peer down. Then there's we have looked at down, and then there is the ready state. I want to look at the ready state. With the ready state, basically the physical and the protocol statuses are both up. They're both up and they're running, and the local interface interbit receives the heartbeat link detection reply packets from the peer heartbeat, right? Here it will set the local heartbeat interface to ready. If it is receiving it, I'm sending the heartbeats and I'm receiving them, then I was looking at ready, then it sets them to ready. If it's receiving them and everything is running, then it sets them to ready. But then the status changes to running. The status changes to running only when multiple local heartbeats interfaces are in the ready state, and the firewall sets the status of the first configured one to running. So if only one interface is in the ready state, the firewall sets its status to running, and then the running interface is used to send the HCIA heartbeat packets and data packets and HCIA link detection packets and VGM packets, and as well as consistency check packets. So basically, to conclude, heartbeat link detection packets are used to detect whether the peer heartbeat interface can receive packets and determine whether the heartbeat link is available. And the local heartbeat interface sends heartbeat link detection packets as long as its physical and protocol statuses are both up. As you can see, as you have discussed in the previous chapters or sections, HCIA heartbeat packets are used to detect whether the peer device or Vmp group is working properly. And these packets can be sent only by running heartbeat interfaces in the Vmp group on the active device. So moving to the next stage, we want to look at the backup modes of our hot standby. We said we need to back up this data, and we can see we have 4 modes. 1, we have 2, we have 3, and we have 4 modes of backing up. So by default, usually it is the automatic, which is enabled on the firewall to automatically back up the configuration and also and the status regularly. So it backs up the configuration commands in real time and also to back up the status of our firewall regularly. So usually by default, it's the automatic mode which is enabled on our firewalls. And this backup method applies to various hot standby networks in most cases. And after our automatic backup is enabled, every time you execute a command that can be backed up on a firewall, the command is immediately backed up because anyway, you're using automatic backup. So if the command is allowed to be backed up, then automatically it will be backed up immediately on other firewalls. And after the automatic backup is enabled, still the active device periodically backs up status information that can be backed up to the standby device. And therefore, the status information of active device is not immediately backed up at its creation. Instead, the information is backed up on the standby every round of 10 seconds after its creation. So on the active firewall, it is immediate. On the standby, at least every after 10 seconds, that's when the information that needs to be backed up is backed up. And the following types of sessions cannot be backed up automatically in the automatic backup, like the sessions created by traffic destined to the firewall. For example, the sessions created for administrator logins on the firewall, it does not back up administrator login, or the TCP half open connection sessions. These ones can also not be backed up in a quick session backup, or because either way it is half open, it has not yet established the connections. And also the sessions created by a UDP first packet but not matching subsequent packets. This also can be backed up in quick session, but they cannot automatically be backed up. So let us look at another mode, which is the manual backup, manual batch backup. This mode here, manual batch backup. Like you hear the word manual, meaning things have to be manually triggered. And in the manual batch backup needs to be triggered by the configuration of the manual batch backup command. You just have to go into your console and you type the command manual batch backup and then you execute the command. So this backup starts immediately after you executing the command, and it applies to scenarios where manual backup is required when the configuration of two devices are asynchronous. So after the manual backup command is executed, the designated active device immediately synchronizes its configuration command to the designated standby device. So after passing this command, the active device will immediately go ahead and send the commands to our standby firewall. And after manual batch command is executed, it also will synchronize its status information, because we have our configuration commands and now we also have our status information. So after it's synchronated, it also synchronizes the status information to the designated standby device with no need to wait for an automatic backup period. So this is almost immediate. Let us look at quick session backup. With quick session backup here, what happens is that quick session backups apply only when the forward and reverse paths are inconsistent on a load balancing networks. Let's say inconsistent forward and reverse paths may occur on load balancing networks because both devices are active and they are able to forward packets. You have both devices on the network. Either packets can be forwarded from this device or they can be also forwarded from that devices. So that's why we have quick session. So it applies in scenarios where we have load balancing. And if the status information is not synchronized in a timely manner, meaning if they're not synchronized in a timely manner and the packets are coming to pass through that other standby device, other active device in the Vmp group, then those packets may also may be discarded. So therefore, we need to make sure that the sessions are synchronized in a timely manner. And that's why quick session backup is required by firewalls to back up status information in real time. Once the status on this machine changes in real time, also that status information is automatically synchronized to the other standby active firewall in the session. So for timely synchronization, this function synchronizes the status information, but not configuration commands. Here it is only looking at the status information. I hope this is making sense. It is only looking at the status information, our session tables, but not the configuration commands. But not the configuration command. Timothy, I am muting you and you're muting yourself. You'll be forced to put you in the waiting room. I don't know what's happening to Timothy. Is Isaac Tamale on the forum?
Yes, sir.
Hey, is it okay if you texted me after the call?
Okay, sir.
All right.
Thank you.
Just text me after the call. I just want to have a conversation with you.
Okay, sir.
All right. Okay, so we are looking at quick session. We are saying it only backs up the status information of the firewall, but not the configuration commands. I hope that is making sense. Okay. And the synchronization of configuration commands can be undertaken either by using your automatic backup or the manual batch backup. And after quick session backup is enabled, the active firewall can synchronize all the status information, all including those that are not supported by automatic backup to the firewall or to the standby firewall. And therefore, our sessions can be synchronized to the firewall immediately when they are set up on the active firewall. So whenever the status changes on active firewall, also the session, the quick session backup can help us to synchronize them to our active standby firewalls. So let us also look at automatic sync of firewall configurations after restart. We want to look at the automatic sync of firewall configurations after restart. And automatic synchronization of active standby firewall configuration after restart are as follows. In the hot standby networking, if one firewall is restarted, the other firewall processes all the services during the restart, right? So if this firewall was the one we're using and we have restarted it for whatever reason, maybe we have upgraded the software, maybe we have changed something that requires restart and we have restarted it. Then as it is restarting, because we don't want our users to try and access the services they cannot, this guy will assume to be the active firewall. So as this guy is restarting, then this guy will start processing all other services during the restart. Okay, and in this period, the firewall that processes the services may have configuration added during this time as this guy is starting. You can maybe change the configuration, change your access control list, or change anything, or the login mode, or enable or permit some kind of traffic to go through your firewalls, depending. So at that time, you can either add or even delete or even modify some of the configurations, right? To ensure that the active and standby firewalls have the same configurations. After when the firewall is restarted, configurations are automatically synchronized from the firewall that processes the firewall. So if this guy, after he has restarted, then configurations are going to synchronize and it's going to get the new configurations from the active firewall at that time. So after restarting, it also needs to make sure that it gets all this information from the firewall, the configuration information, because anyway, it could have changed or it could have even been deleted. So it needs to update its information and configuration information. And only the configurations that can be backed up can be synchronized, such as security policies and NAT policies. And configurations that cannot be backed up, such as OSPF and BGP, remain unchanged. Configuration synchronization can take up to 1 hour and subject to the amount of configuration. During the synchronization, you are not allowed to execute configuration commands that can be backed up between firewalls. Okay, so basic networking and configuration of dual system hot standby. In dual system hot standby networking, the firewalls usually work in routing mode, and the downstream switches separately connect to the firewall through two links. In normal cases, a firewall functions as an active firewall, right? This firewall A, it functions as active firewall. And if the upstream or the up-down link of firewall A goes down, if one of those links goes down in normal cases, firewall B will automatically come up and assume the role of the firewall, and then the switch traffic is transmitted through firewall B. So when upstream and downstream service interfaces on the firewall work at layer 3 and connect to layer 2 devices, configure Vmp groups on the service interfaces so that Vmp group can monitor layer 3 service interruptions through the Vmp groups. Basically, you just have to configure your groups, have them there, have your virtual IP address set, make sure these guys have to be running in layer 2 mode, and then these guys will be able to communicate effectively. How you configure, just go on your terminal, you will see how to open the terminal, and then you type in these commands here, you open the slides and you go through the terms, but you just go to the terminal and you just type in those words. And after the active or standby parameter is specified, then the VIP group is added to the active or standby group. So you choose what to specify, either active or you select standby. And if you have chosen active or standby, then that firewall will be added to that group depending on what you have chosen. And we are saying that up to 255 VIP groups can be configured on each common physical interface. That is the gigabit Ethernet interface. Just a moment, excuse.
Everything is gone. Oh, nizafaa kufina nkumbula. Wasira. Kama na jini kapachani mtoto mo mimi. What do you mean? Don't know where I pressed.
All right, so excuse me about that. We were looking at how we can configure the Htrp on the command line interface. So you just have to specify a heartbeat interface. You go ahead and open your terminal, and after opening your terminal, you just pass this command of Htrp interface type, and then you specify the interface number, and then you either choose whether it's going to be remote or you're going to be using an IP address, and you specify either if it's going to be IP version 4 or it's going to be IP version 6. So enable the Htrp in your terminal. Please mute your microphones. So enable the Htrp, and then you go ahead and also enable standby. You'll go through these slides in your free time. Basically, these are just configurations. After when we have set up our firewall, just go through them and see how you can enable those things physically. And to view the status of your group, you just go to display via P interface, and then you specify the interface, and then it will display for you all the information, whether it's gigabit Ethernet, virtual router 2, active mode, this is a virtual IP, this is a MAC address, blah, 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 blah. All those details will be displayed to you. And to view the status of the active firewall, you just say display Htrp state. and then it will show you the status of which firewall is active. Okay, so using the graphical or the web user interface, you can configure still using the web UI. You can just go choose high availability. When you go to high availability, select dual system hot standby and click edit to configure dual hot standby. These are basically steps on how you can configure them. I'll skip through it and we shall just have to do it physically. Sorry, with me while demonstrating on a physical machine, because here it doesn't make a lot of sense me going through them. And there's a quiz here. Question number 1, which says HRP enables active firewall to synchronize all configuration and information to the standby firewall. Therefore, the configurations and information are still available after a restart. As a result, no information needs to be configured on the standby firewall. Is that true or false?
Yeah, true. Yes, it's true.
People are saying,
No, it's
Kalimba
false.
is saying
It's
it's
false.
true.
Mic check.
Yes, please.
It's false.
Mic check.
Yes, why are you saying it is false? Someone was saying mic check. Someone was saying mic check.
I'm saying it's false because the moment you restart the firewall, everything is
It's synchronized. Thank you, Emmanuel.
Yes.
Remember, I showed you and I said we have four categories of backing up. We have automatic, we have manual, we have quick session, and we also have after a restart, isn't it? And we said during the restart, the standby firewall assumes the responsibility of the active firewall. And this time you could either add or delete configurations, right? And after firewall A powers up and is restarted, there is need for firewall A to get everything that is being done on firewall B in his absentia and synchronize it with his own information. Therefore, meaning that information needs to be configured on the standby firewall. Information has to synchronize, right? Because now he has assumed role as a standby firewall, but now he has to, synchronize information with the information of the active firewall at that particular moment. So after restarting, still information needs to be configured on the active firewall. So that makes our answer to be false. Okay.
False.
Yes.
Mic check, Mr. Samuel.
Yes, please.
Thank you for the clarity, but the reason as why I was saying true, or I thought it's true, it's because you said active firewall, is it backs up or rather records information in real time. So I thought that it starts from where it ended or stopped before going off. But thank you for the clarity.
Yes, thank you. Because in the process of updating that information in real time, it's actually configuring, it's actually getting new configurations. I hope that is making sense, right? It's getting configurations from the active firewall, right?
Oh yeah, true.
Okay. So which of the following, question 2, which of the following protocols is used to control the switch over of all Vmp groups in the firewall dual system hot standby networking?
VGMP.
VGMP, HRP.
VGMP.
MP and HRP.
Okay.
And
Okay.
HRP.
Okay. HRP is a protocol that is used to detect just
VGMP.
Yes, so it is
Just
VGMP.
detect.
This is the protocol that controls the switchover. This one just detecting to see if these guys are actually alive and also sharing the session information and configuration information, right? So our answer is VGMP.
Yeah.
All right.
Mic check.
That brings us to the end of that summary. Yes, please.
Mr. Sandy, so on that question, on the second question of the quiz, if VGMP wasn't there, then HRP could be the answer?
then it would be a different question to that if it wasn't there. And it is also single choice. Maybe if you came across it and it was multi-choice, but in this particular case, it is single choice. Okay. If it was multi-choice and they require you to have more than one answer, then definitely you go with those two, right?
Okay.
Maybe Mr. Samuel to discuss more with the gentleman that has been previously on.